Here we go. Here we go. Come on. Get up. Get up. Get up. Get up. Get up. Get up. Yeah, there it is. Nice.
Hello and welcome to another one of these ADD videos. That clip was too funny. We'll talk about that here in a couple of minutes. But let's just talk about work in general. What is work? Well, work is force dot a distance. That's a dot product right there. Which means the alternative definition of dot product applies where if we only know the magnitudes and the angle between them, not the actual vectors, then we can use magnitude times magnitude times the cosine of the angle between them. Keep in mind, because this is a cosine expression, only forces that are parallel will matter. And if you do have an angled force, remember those angled forces have components to them, and you only want the one in red that's parallel. Let's say if the motion is in that way. Or if the motion's up, you'd only want the one in orange here I'm drawing. If I can draw a straight line. So, just like you've been breaking up the forces into components up until now, nothing's new. The SI unit for work is a joule, and that can be broken down as a Newton meter, which kind of makes sense. The force is measured in newtons, and the distance is in meters. A couple of conversions that you might read or see. So let's go back to our good friend, the bodybuilder that used completely incorrect form and lifted all with his back, and as a result paid the price. There's no need to be macho when you're in the weight room, but when you are in the weight room, those of you that do go exercising with weights, so if you were to lift or weight, there's two forces occurring there. The first force is the force of the dumbbell on your hands. The second force is the force of the hands on the dumbbell. One of the forces creates negative work and the other one creates positive work. How do we tell? Well, if our force is in the direction of the movement, then it's positive. Okay, and by contrast, if it's opposed, to movement, like that kind of scrattle off on the movement thing. That's what happens when it's 3:40 in the morning. Work is less than 0. Alright, so which one of these works is greater than 0? Which one is less than 0? Is it this one or this one? Let's ask about positive work first. Well, whichever work is going in the natural motion, or the motion of the movement. So in this case, the dumbbell is going to go down as we start our exercise. So in the motion of downward motion, or in the downward motion, the force of the dumbbell on the hands is going to be going in the same direction, right? Because the dumbbells are going to be pushing down as well as the motion of the weight. So this one wouldn't be a positive work, whereas this one that's opposing it, your hands are keeping the weights from falling down, so they're doing the negative work. Alright? So when you're doing these problems, there's two ways you can approach them. One way is to do the sum of the forces in the x and the sum of the forces in the y, and then pick one that's parallel to the motion. This is the symbol for parallel to straight lines. And then 3 multiply times your distance traveled. Okay, that was method 1. Method 2 is to look at it from a work perspective. And right away pick the parallel forces. And then multiply just those forces by distance. And actually these aren't forces. This will do the individual works, or the work contributed by each force, and then take the difference in the forces. Okay. We will also be using the concept that work is equal to the change in kinetic energy, and work is equal to the negative change in potential energy to establish the work energy theorem, which will, when we set those two equal to each other, you don't really need this derivation part of it, but if you were to distribute that through, and get all your K1s and U1s on the one side and K2s and U2s on the other side, you would end up with the conservation of energy law. And this is basically if there are no other forces besides gravitational force. The theorem changes a little bit if there's other forces involved on the left hand side, we add work other. Okay, and quick refresher on the two energy formulas. There'll be individual videos for those, but kinetic is 1/2 mass times velocity squared, and then the potential energy is always mass times gravity times height. And there's always an interplay. What will happen when you do these problems is one of these will go to 0 on each side, and the other one won't, because potential energy will be maximum, while the other one is minimal, and vice versa. Alright, I hope that has clarified things for you. Make sure you watch the example videos. Practice, practice, practice. Thank you and have a nice day.